Greetings. If you're watching this video right now, that means you're participating in a virtual event sponsored by the Ada Community Libraries. My name is Henry Charlier, and I'm a professor at Boise State University, Department of Chemistry and Biochemistry. I am a biochemist by training, and I do research in the area of cancer and chemotherapy. But when I'm not teaching or doing that research, I become Dr. Picklestein. Hello, Dr. Picklestein here. I am going to have some fun with you today. I made a bunch of videos of me out in my yard and in other locations doing some of my favorite demonstrations, and I was able to collect video on these. And so that's what I'm going to share with you today. To begin with, I am going to use my wireless microscope. And if you're familiar with the term TMI, which means too much information, usually people say that when people are overly open about themselves and share more than what other people want to know. Well, thanks to my microscope, I'm going to show you a close-up TMI look at yours truly, me. And I think you will be disgusted. And I think it will be interesting too. Let's have a look. I'm going to see if I can get my dog underneath the microscope. Boy, I have no idea. Come here, Racer. Oh yeah, look at that. He's got dandruff. Look at all that junk on his hair. That's his head hair. What a good looking guy. Oh, he did not like that. He does not like that at all. Okay, so now I'll show you my hair. So this is what human hair looks like. Now I shaved my head, so you can see it's pretty cool. Ooh, I got some goobers in my hair or something. Did I wear a hat today? I must have. I took a shower and everything, but it looks like there's dirt and stuff. Look at, weird. Ooh, I know what I've been dying to look at. Let's see if I can find it. I have something growing on my head that drives me crazy. It's like a little lump. It's like maybe it's, oh, I'm trying to find it. Oh, there it is. It's like a little mole. You see that? A little different. And then I think I have something else like hit my head. And I think I have some kind of a scab or something. It's really disgusting. Humans are really disgusting underneath a microscope. Turns out. Oh, wow. Okay, now I'll try my beard. Let's see what that looks like. Oh, look how much gray hair I have. You can see the skin underneath. Ooh, kind of neat in its own special way. Here's my ear. My ear, I know, is pretty disgusting. Look at that. Okay, I'm gonna pump up the magnification and see what happens with my ear. Oh man, look at the blood vessels. I got dirt in my ear too. Oh, that's disgusting. I don't even know what half this stuff is that I'm seeing here. Ugh. Lots of hair in my ear. Let's see. Oh, look at that. A lot of blood vessels. All right, let's try my eyebrow. Oh, interesting. Oh, what is all that junk? How is it that I have all that dirt? I swear I did take a shower today. It's hard to tell. How about that? Whew. Here's my favorite one. Let's see if I got any boogers. Ugh. That's up my nostril. Oh, there's kind of a booger start. You have to really be comfortable with your body to be able to do stuff like this and not knowing that other people are going to see it. It's pretty disgusting, but really fun. See if I can put it in focus. That is my wedding ring. It's gold. And boy, I'm pretty rough on things. Look at all the scratches. It's crazy how bad I am. Okay, let's see. Oh, here's some, let's see. Here's part of my skin. Yep. Let's see. Okay, that's my arm skin. I do not have a lot of hair on my arms or my legs. I did cut myself recently. Oh, here's a cut. Let's take a look at the cut. You know, I think I'm going to take another shower. This is ridiculous. So dirty. I did do some lawn work, come to think of it. That's probably what happened. I cut the lawn and I got myself nice and dirty. Here's a fingerprint. You can see the little oil droplets that's from my skin. You see that? How it can secrete. Oh, I really do need to take another shower. Look how dirty. I guess when you mow the lawn, you do get dirty. Wow. That's disgusting. Here's the fabric of my shirt. My Patagonia, whatever that means. Oh, that's kind of cool. That's cleaner than my body. And here's my pants. And I'm wearing shorts. I'm wearing a pair of shorts. That's pretty cool. So I hope you enjoyed that little look at me. You'll never look at me the same again. Now, I want to introduce you to my colleague, Lady Argentum, and she's going to show you an amazing bit of chemistry that she can do that will look like magic, and it involves silver and glass. Have a look and see what you think.
Okay, today we're going to do my favorite chemistry experiment. I have a plain glass vase. This only works with glass. I like this one because the mouth is a little bit bigger. I'm going to start out, notice first I have my safety gear on. I've got my lab coat, my safety glasses, and gloves because this experiment uses silver nitrate and it stains really bad, so I have to wear gloves. In fact, I just noticed this glove has a big silver stain on it already from my last time. I'm going to start out by filling the vase with hot water. All that does is heat up the glass because chemical reactions go faster with heat. So I'm just going to let that set for a minute with hot water in it while I measure out the chemicals. This is the silver nitrate. Even though it looks like water, it does have silver dissolved in it, and that's important to remember. So it looks just like water. This is potassium hydroxide. I'm just going to measure out everything I need first, and then I can start the reactions. This is glucose, just a simple sugar. And this is ammonium hydroxide. So I'm going to start out by putting a few drops of ammonium hydroxide, that was more than a few drops, into the silver nitrate. You can see that it turns slightly brown. If I continue adding slowly, drop-wise, the brown color will disappear and it goes back to being clear and colorless. Then I add the potassium hydroxide and it turns very dark brown. Then I go back to the ammonium hydroxide, but this time I want to stop before it turns totally colorless. I want just a slight brown color left. So I'm going to stop right there. And what I just mixed up, this is called a Tollens reagent. And if I were to let it set and start evaporating, it would take a week or two, but it gets highly explosive. So that's why I mix it up fresh. Now my glass vase is hot, so I'm going to dump the hot water back out and add the glucose directly to the vase, and then the fresh Tollens reagent, and then cover it with my hand and shake. And you can see something is starting to happen. But this is where it gets really interesting. See how dark it's getting? And now can you see that it's turning silver? So then if I dump that out, that's where the stain on my hand comes from. And now I have a silver plated vase. The silver nitrate that I started with has plated out on the inside of the vase as a thin coating of pure silver. And I forgot to bring my water bottle with me. So I'm going to rinse this in the sink just a couple times and then show you the inside. So if you can see this, hopefully you can see down inside there, it looks gold inside, which I really like. But this is a permanent coating. It's thin, but it's pure silver from the silver nitrate that I started with. But what's fun about this is that if I want, sometimes when we do this experiment and demonstration at presentations, students ask, can you take it back off? Yes, I can. If I put nitric acid in it, I can take this back off and turn it back into silver nitrate. So because I had ammonia in here, I don't want a strong acid-base reaction. I'm going to rinse it a couple more times, and then I'll add the acid and show you how it comes back off. So now I have my silver plated vase. I'm going to put some nitric acid in it. This is 50% diluted 1:1. Just going to put a little bit in. And as I swirl it, you can see that it's redissolving the silver coating. And then what I'll do is I'll go back over to the sink and put my hand over this and shake it really well. And then I can just pour this back into the acid bottle and reuse it again and again. If I weren't starting with a brand new vase that I know is clean, then I would use the acid to clean the bottle in the first place, because if the glass is not really, really clean, it won't plate well. So I'm going to step to the sink and finish rinsing this, and I'll be right back. Okay, so now here is my freshly cleaned, re-stripped vase, ready to silver again.
So what did you think of that? Lady Argentum taking a bottle and turning it into silver, and then taking the silver back off again. Chemistry is amazing, and it teaches us so many cool things. I think you will enjoy now. The next thing we're going to do, I am going to show you my newest methanol cannons. They explode. And then after those explosions, I'm going to go right in and launch things from those cannons. A lot of times I've shown people my cannons, and these are new ones, by the way. I totally made new ones, so we'll have to learn more about them. So even if you've seen my other cannons before, these are going to be different. And then so many times I get asked, what would happen if you put something in the cannon? Would it shoot something out? Well, we're going to find that out too. And I have these little bouncy balls that I bought, and we're going to see if they launch out of those cannons. So let's take a look. The cannons shown in this video are dangerous and should not be attempted at home. I have the proper personal protective equipment and a functioning fire extinguisher. The cannons are an extreme fire hazard and if not done correctly could lead to significant property damage, injury, and possibly even death. In other words, don't do this yourself. Just sit back and watch me and see if you can solve the mystery that will be presented. Well, it's my great pleasure to introduce you to my newest arsenal, my cannons. And I'm in my backyard to do it because I really love lilacs. Anyway, here are my cannons, and I'm going to introduce each one to you and then kind of explain them and how they're different from one another. Going from left to right, we have Tiny Tina, Chuck Norris, that's what that one's called, and then Black Beauty, and then the one next to it with the camouflage is Duke, and then next to it is Dangerous Donna, and then the one next to it is Joyful Jenny, and then finally Big Brutus, named after my sister. So, what makes them different? Well, obviously, you probably note that there's three general sizes. There's the Tiny Tina size, and these four in the middle, they're kind of a mid-range size. And then there is the one on the end, the Big Brutus size, is the biggest, okay? So in terms of small, medium, large, which size do you think is going to be the loudest? If you've ever seen my cannons before, you know that I put some fuel in them and I ignite them, which I will be doing. And I want you to kind of take a guess right now. What do you think, which size range do you think will give the loudest? We have, like I say, the small, the medium range, and the large range. Now, what makes these things tick? Well, I'm going to start by describing using Big Brutus, because Big Brutus is big and easier to see into. So inside of Big Brutus, you can kind of see that there is something called metal baffles. And there are 3 metal baffles, and you can see that they go about halfway across. All right. And so there are 3 of them. They're staggered. So one baffle goes halfway across this way, and then the second one goes halfway across that way, and then the third goes halfway across that way. And so we have these baffles. And I'm going to say that Tiny Tina, Dangerous Donna, and Big Brutus all have the same design with regard to the baffles. So we'll pay attention to Tiny Tina, Dangerous Donna, and Big Brutus because they all have baffling going halfway across. Now let's show you what's different about the 4 middle ones. We already know that Dangerous Donna has those 3 baffles staggered, each one going halfway across. So we know that that's true. Now we have Chuck Norris, and Chuck Norris is very handsome. But if you look inside of Chuck Norris, we see no baffles whatsoever. And so it's just a hollow tube straight on down. Then Black Beauty has just one baffle in the middle, which I'm holding my fingers by where that baffle is. And then we have Duke. And Duke has 2 baffles. One, I'll show you where they are. One by this at the top, one at the bottom. And they are also staggered. We talked about Dangerous Donna, and then that leaves us with Joyful Jenny. Joyful Jenny, I tried to make it, and you can kind of see, so that the baffles go a little bit further across than halfway, maybe 2/3 to 3/4 of the way across. And so I wanted to, and it has it at 3 spots. Here, here, and here, and just like with the others, they are staggered. So In the terms of the middle four, which one of those do you think will be the loudest? And so we'll see how that goes. Now, in order to make the measurements, we will do it two different ways. One, we'll do it by ear, which, since you're going to watch a video of this, it'll be harder to see. Determine that, but I'll tell you what I think based on my hearing. And then I also have a decibel meter to measure the actual decibels of each explosion as they occur. And you will see the ratings on that. And then we'll try to put it all together and answer the question, which will be the loudest in terms of size, and then which will be the loudest in terms of the amount of metal baffling, and to make everything equal, those are all the same size. So that's what we're going to do. I want you to think about what your hypothesis is going to be. Which one will be loudest in terms of size, which will be loudest in terms of the amount of metal. And truthfully, I'm not sure until I do the experiment myself. And then once we figure that out, we'll have to do some more analysis to think what next. Okay, let's light them off. Cannon number 1, which is Tiny Tina. Here we go. Chuck Norris. Chuck Norris is pretty loud. The Black Beauty. Duke. Dangerous Donna. Now it's time for Joyful Jenny. And last but certainly not least, Big Brutus. All right, so let's try to bring this video to a close. So I'm showing you first the first set of questions, the first question I asked you, which is which of the three sizes will be the loudest. And in each case, I have, for each of the cannons, I have baffling that goes at 3 locations, like I showed you earlier, that go halfway across. And based on my ear, I would give a different answer than based on the decibel reader. So Tiny Tina had a measurement of 110.9 decibels. Donna, Dangerous Donna, had a measurement of 120.7 decibels, and Big Brutus 123.7 decibels. So based on the decibel meter, Big Brutus would be the loudest, next loudest Dangerous Donna, and then the softest is Tiny Tina. Yet by ear, to me, it sounded like Dangerous Donna was the loudest, and then Big Brutus, Tiny Tina. So you made your decisions based on the amount of metal that's present, and so let's go through the decibel readings again. So decibel wise, Chuck Norris had 110.9, sorry, 119.4. Black Beauty had 118.1 decibels. Duke, 116.4. Dangerous Donna, 120.7. And Joyful Jenny, 118.5. Now, this was the most surprising group of cannons for me, because when I've done this in the past with other cannons, my other cannons, these are replacement cannons, the one with no metal always was the softest, and the one with the most metal was always the loudest. But we didn't find that based on, and that was based on ear. And if I were going by ear, I would have said Chuck Norris was louder than I expected. So I would have went Black Beauty, Chuck Norris. Duke and Chuck Norris to me felt about the same. Dangerous Donna, and then Joyful Jenny. That would be the order that I had. But the decibel meter disagrees. The decibel meter didn't really find an exact trend. In fact, it kind of went all over the place. So if I were to go by ranking by decibels, boy, would this have been. I'm going to arrange them according to, from lowest to highest, according to what I'm seeing in decibel readings. So I'm going to rearrange this, and I'm going to do it right now. And this is what you get. Duke was the lowest, followed by Black Beauty, followed by Joyful Jenny, followed by Chuck Norris, followed by Dangerous Donna. This did not follow anything like I would have guessed based on just the decibel readings. This is what we found. How does that compare to what you thought? Sometimes science doesn't give clear-cut answers, and the truth is, if I really wanted to do this much more rigorously, which I really don't, I think this was good enough for what I'm trying to get done. The truth is, I would have repeated this several times and calculated averages and standard deviations and done more statistics and get a better sense of what the real trends are. We are going to do Joyful Jenny. That didn't do anything. Dangerous Donna. Nothing. Not very good for Dangerous Donna. Big Brutus is going to be fired off. Well, today I'm at Boise State. Came in for a little bit, and so I wanted to test you guys to see if you can figure out one of my most favorite riddles that I give people, a little puzzle to solve. And so it's going to work something like this. So I have a spool of string that is available for your observation. So hopefully you can see it just fine. And I have it so that it's wrapped over the top of the spool, and I can pull it and you can see how it unwinds, okay? So in this first part of a two-part puzzle, I am going to put this on a table, which I'm going to transition you for now. So as I said before, it's wrapped over the top. I'm going to put this on the table. See if I can get it to, let's see, stay flat here. Okay. And I'm going to pull the string in this direction. So the question I have for you is, under this set of circumstances, where it's wrapped over the top, and I pull it that direction, which way will this string go? Will it go that way? Will it go that way? or will it stay still? Now that's the question we have for you. I want you to pick one now. What's your hypothesis? That way, or stay still? To my right, to my left, or stay still? Okay, now we're going to do the experiment. Here we go. Now, how many of you got that? Hopefully, some of you might have, some of you might not have, but that's the cool thing about a hypothesis. Even when you get it incorrect, you can change it to the right answer. Now we're going to try one more. Here we have this wrap from underneath. So the last time I had it wrapped up top, over the top, now it's underneath. And so you can see when I pull it, look what happens. Look at the way it unwinds. So you can kind of see how it unwinds. Okay, now I'm going to do the same thing. And I want you to make your decision. Is it going to go to my right? That's the way it went the first time. Is it going to go to my left? Or will it stay still? I want you to pick which one you think it's going to be. And then we'll try it. Okay, now I'm going to do it. And let's see how you do it. Okay, here we go. We did it did you see that? It still went to my right. No matter which way it was wound, over the top or over the bottom, it still went the direction I pulled it. And that's probably what we could conclude from this, that this thing will go the direction that it's being pulled. It's going to go the direction of the force. Now, sometimes people ask me, what if I pull it fast or I pull it slow? Will that make a difference? Well, I just pulled it slow. What do you think will happen if I pull this fast? I'll put it so it's wrapped underneath. Okay, so it's wrapped this way again, so the way I just had it. And I'm going to pull it fast, and I want you to figure out which way will it go. Will it go to my right, to my left, or stay still when I pull it fast? Okay, so I got to set things up real quick here, because I am going to be pulling it so hard. That means it's going to go fast, so I have to be prepared by putting something on either end to prevent this from going flying off into a wall, because that's how hard I'm going to pull it. So I got 2 chairs with nice cushions, and I'm going to go ahead and I'm going to pull it. Let's see what happens. Ready, set, go. So hopefully you saw that even when I pulled it hard, it still went the direction of the force. So that's something we can learn from this experiment. So hopefully you got something correct, and even if you didn't, you now know. You learned something. It doesn't matter which way this spool of string is rolled over the top or wound under the bottom. Instead, what matters is the direction I pull it. So today's theme, we are going to do some experiments with these little tiny balls that I have here. We got them, they're let's see, I got Spider-Man and Baby Shark, and I don't even know what this is. I'm sure many of you will know, but it's cute little dogs, but I'm sure it's some character that I don't know. And then, of course, Minnie Mouse. Okay, so we're going to try to use some liquid nitrogen on these balls to see what happens. Here's what happens when I just throw it on the ground and bounce it. So let's see what happens when the Baby Shark ball winds up getting frozen. Ah, I wish I had a frozen one of these. That would be good if I had frozen. Baby shark is going to have to do though. So we're going to go ahead and pour some liquid nitrogen in here. Okay. So I got a little liquid nitrogen in here. All right. And let's put this in there. There we go. There we go. Now that should do the trick. Should be interesting. All right, let's pull this thing out. Get the rock out first. Okay. I have to get this ball out somehow. Okay, I'm just gonna go ahead and pour this in here. There we go. Here we go. That was pretty good. Let's do it again. Okay, let's try it one more time. And I'll pour this out and grab it. And this is the dog. Let's try it again. Here we go. All right, I think this one's good. Okay, get that out. I'll put this one in. I'll pour this in. I'll put this in like so. Okay, here we go. Okay, I got liquid nitrogen. I'm going to make a liquid nitrogen and water bottle rocket. I'm hoping this works. It's been a while since I've done this. Okay, here we go. Okay, now we're going to do the Battle of the Liquids outdoors. I don't know if I've ever tried it outdoors, so we'll see if it's any good. Hopefully it will be what we need. So we're going to put minus 195°C liquid nitrogen against boiling water. I just boiled this in my house so we can see that it's boiling, and we're going to go ahead and see what happens when I suddenly throw a bunch of the hot water in this liquid nitrogen. And so let's see what happens. 3, 2, 1 more thing. We need to make sure that you guys understand that I have safety gloves, glasses, and I'm standing back, and I don't want you to ever try this at home if you ever do manage to get some liquid nitrogen, because it can be dangerous. Liquid nitrogen can be dangerous. Okay, here we go. 3, 2, 1. That was awesome. I totally love working with liquid nitrogen. Did you notice that as I let that one bottle go out of my hand, it immediately exploded? I couldn't believe that. I had had that happen only once before, and it had been so long since I've done that. That's why I went and bought those Kevlar gloves that I was wearing. It is just crazy. I can't get over how lucky I am that I don't hurt myself when I do stuff like that. Anyway, you can see why it's dangerous. And then, did you see how high that cloud went above my roof of my garage? I love that one too. I have so much fun. Well, I think there's a little bit of time left for one bonus video, and I'm going to just end on this. I'm going to show you what I call my applause machine, because when it's done, it gives you a big hand. I'm going to do 2 different versions of it. And so hopefully you enjoy this too. Have a great day. Bye-bye. I'm going to use a lot too. Because the more the better, okay? And then I'm going to add some of this iodine to this, because they're both liquids. But now this iodine is actually turned it brown. Maybe even an orange color. Okay? So here's where the fun part comes in. I'm going to fill up one of these balloons with some baking soda. Some baking soda. See if I can get the baking soda to go in here. Yep, it's going in. It's going in. Come on, baking soda, you can do it. All right, and then I'll add some starch to the top of this because it needs some starch too. And I told you this is going to make a mess. So I got the starch in there. I'm going to use this stick and see if I can just get it to go in there. And then I'm going to see what happens. So let's see if I can make this work. So you see how I have this now. And I'm going to go ahead and dump it and see what happens. Whoa! You see what's going on? Whoa! Is it gonna blow? Oh boy, it's going pretty good. Oh, that was awesome. So this is not, I repeat, this is not a actual rubber glove. I wonder how well it can even blow up. I'm gonna try. So it kind of blows up. All right, I'm gonna go ahead and put in, I'm gonna go ahead and dump in some pouring in some baking soda, and now I'm going to add in some starch. Okay, we'll pour in some of my vinegar again. Okay, I'll pour in a little more iodine. Okay, oh boy, this is going to be spooky. I wonder if I can even hold it good enough. Okay, here we go. Oh boy. Oh boy. Oh, look at that go. That's why it's really important to have your safety glasses on. Oh, it's living. Hey, it's my applause machine. I'm giving everyone a big hand. Look at that. Oh no. I'm gonna move my phone. See what happens. Whoa. You see what's going on? Oh. It's gonna blow. Oh boy. It's going pretty good. Oh, it's, ah. Oh boy. Oh boy. Oh, look at that go. That's why it's really important to have your safety glasses on. Oh, it's living. Hey, it's my applause machine. I'm giving everyone a big hand. Whoa! You see what's going on? Whoa! Is it gonna blow? Oh boy! It's going pretty good.